Hello students, welcome to Misostudy and welcome to my class. Today we are going to discuss few questions from the chapter D and F block element as well as coordination compound. Is it clear to you? Yes sir. Look at the question what is given. Read the question. First of all I am briefing this chapter, that is D and F block elements. Again I am repeating, we will discuss the chapter D and F block elements. Clear? We know there are three series of D block, that is 3D, 4D, 5D and 6D series. 3D starting from 3D1 to 3D10 and 4D series starting from 4D1 to 4D10. 5D series start from 5D1 to 5D10 and 6D series start from 6D1 to 6D10. Is it clear? Yes sir. 6D1 to 6D10. Now in 3D series there are total 10 elements in 3D series. In 4D series again there are 10 elements, and in 5D series again there are 10 elements. Is it clear? And in 6D series there are again 10 elements. Is it clear? Yes sir, absolutely. Now the thing is 3D, 4D, 5D and 6D. Now we can say in D series there are overall 40 elements. Do you remember? Yes sir. All has electronic configuration, that is NS2 N-1 D1 to 10. Again I am repeating, NS2 N-1 D1 to 10. Now the thing is, among them 36 elements are transition metals. 36 elements are transition metals and the rest remaining 4 are D block elements. Okay, again 36 elements are transition metals and remaining 4 are D block elements. Now the thing is, why transition metals? Because they have partially filled D subcell. Again I am repeating, they have partially filled D subcell. Now the thing here is they have partially filled D subcell. Now the thing here, if they have partially filled D subcell, that is the compound of transition metals are always colored due to DD transition. If they have partially filled D subcell, that is they are paramagnetic in nature. If the compound of transition metal have partially filled, that is it contains unpaired, partially filled in the sense that is if it contains unpaired number of electron, then they are paramagnetic in nature. Is it clear to you? Yes sir. Now the next one, colored and DD due to DD transition. Okay, now the second one what we are going to discuss here, that is you have to observe the atomic size in this chapter. What are the atomic size relation when we move from scandium to Mn, then Fe, cobalt, nickel, then copper, then Zn. What we observe, then first the due to the increase in effective nuclear charge, because we know D have poor shielding effect. Yes, due to the poor shielding effect, first that is it decreases up to Mn, then after all have almost equal radius, almost equal, slight variation are there due to the reason the effective nuclear charge and the shielding effect. Now the question arises, the basic character of the transition metal monoxide follows the order. When we move from scandium, titanium, vanadium, chromium, and then Mn. What we observe that up from scandium to chromium, the size decreases, then after the size are almost same. What I'm telling, in case of Mn, Fe, then Co, Ni, Cu, and Zm, they have almost same atomic size. So in this case, when we move from titanium to Fe, what we observe, there is a decrease in the size of the atom. If there is a decrease in the size of the atom, then what will happen, that is the basic character of the monoxide, basic character of the monoxide decreases. Is it clear to you? What I am telling, the basic character of the monoxide decays. So what is the order? Ti, Vo, Cro, and Feo. This is the correct option. So for question number 64, we will say that is D is the correct option. Now I am going to rub this part and let's move to the next question. Now let's move to question number 65. What is given here? The correct order of decreasing second ionization energy. Again I am repeating, the correct order of decreasing second ionization energy. That if I write here titanium, if I write here vanadium, if I write here chromium, and if I write here Mn, what we observe, when we move from titanium to Mn, the size almost decreases. Then after chromium, that is Mn, Fe, almost equal size. Now what is the electronic configuration? We write here 4s2 3d1, in vanadium 4s2 3d2, and in chromium 4s1, wait for a moment, 4s2 3d2, 4s2 3d3, 4s1 3d5, and in Mn we will write here 4s2 3d5. This is the case. Yes. Now second, first when it lose one electron, then the ionization energy, the electronic configuration is 4s2 3d1. Yes. Then when it lose one electron, that is 4s2 3d2. Yes. Here we will write that is 4s0 3d5, and the second one is 4s1 3d5. Now again when it is losing the second electron, that is the electronic configuration here is pardon my friend, pardon, there is a missing. This is electron removed from 4s, then 3d. I am so sorry. 4s1 3d2, 4s1 3d3, 4s0 3d5. Okay, 4s1 3d5. This is the configuration, 4s1 3d2, 4s1 3d3. Okay. Now for second we will write here 4s0 3d2, then 4s0 3d3, then 4s0 3d5, and the 4s0 3d4. Is it clear to you? Now they are asking the correct order of decreasing second ionization energy. Now tell me, what is the correct option? Which will have more? Look at in this case. Now when we consider chromium, look at, after releasing one electron, it has electronic configuration that is 3d5, half filled. If half filled configuration, we know it is more stable, so it requires maximum amount of energy to release the next electron. So the answer is chromium first, then there come Mn, yes sir, Then which one? Then there come vanadium, and then there come titanium. By looking at the electronic configuration, you can easily assume, you can easily judge that is chromium, Mn, vanadium and titanium. So for this question, we will say that is D is the correct option. Again I am repeating, that is we will say D is the correct option. Now, when a brown compound of Mn, listen carefully, when a brown compound of Mn is treated with HCl, it gives a gas B. Again I am repeating, when a brown compound of Mn is treated with HCl, it gives a gas B. The B taken in excess react with NH3 to give a explosive compound. Simple. The brown compound of Mn, is my friend MnO2. Yes, when MnO2 is treated with HCl, it gives you MnCl2 plus H2O plus Cl2. It gives a gas. This is a gas, this is B, chlorine gas. Excess of B, that is Cl2, when treated with NH3, it gives you NCl3. This is C. This is explosive compound. Is it clear? Again I am repeating, this is explosive compound. Okay, now look at MnO2 plus HCl. It gives you MnCl2 plus H2O plus Cl2. This is a gas B. Okay, when B takes in excess, react with NH3 to give C, that is the explosive compound NCl3. The compound A, B and C. What are A, B and C? A is MnO2, B is Cl2 and C is NCl3. Simple question, I think you can do. Now, in D and F block element, you have to focus two important compound. That is D block elements. D block element, that is first K2Cr2O7 and KMnO4. All the properties, all the method of preparation, everything related to K2Cr2O7 and KMnO4, you have to focus because they act as a strong oxidizing agent and a very important inorganic compound. Focus on this one for D and F block element. Then F block element is not so much tough. Just go through the physical properties like lanthanide contraction, actinide contraction is enough for you. But D block element, all the properties physical or chemical, and after that you have to focus these two important compound, sufficient for you to cover this chapter. Now I am going to wrap this part and let's move to the next question. What is the next question? Question number 67. It is given here a complex, PTCl4. PTCl4 into 5NH3. PTCl4 into 5NH3 shows a molar conductance of 402 molar conductance it is showing, that is 402, okay, per ohm centimeter square per mole. This is the molar conductance. Again I am repeating, 402 per ohm, 402 per ohm centimeter square per mole in water, okay, and precipitate 3 mole of AgCl with AgNO3 solution. That means to say, when it combines with AgNO3 solution, AgNO3 solution, it gives 3 moles of AgCl. It gives 3 moles of AgCl. Is it clear? Yes. Again I am repeating, that is, in water and precipitate 3 moles of AgCl with AgNO3 solution. What is the formula? The formula of the complex is, you have to find the formula of the complex. That means to say, there should be at least 3 chlorine. There should be at least 3 chlorine out of the box in this particular compound. So we can arrange like this: PTNH3 whole 5 Cl into Cl3. This is the formula. This should be the formula of the compound, because now it has coordination number 4 and there is 3 Cl outside the block, because it will break like this: PTNH3 whole 5 Cl3 plus and 3 Cl minus. When treated with AgNO3 solution, Ag plus and NO3 minus, then what will happen? It will move here and form AgCl. So 3 mole, because there is 3 chlorine. So we will say the formula of the compound is PTNH3 whole 5 Cl. Where is PTNH3 whole 5 Cl, Cl3? For this question, we can easily predict that is C is the correct option. Am I right? Yes sir, you are absolutely right. And now I am going to rub this part and let's move to the next question. What is the next question here? Question number 68. Now, it is very good question. Jahn-Taylor effect is not observed in high spin complex. Why Jahn-Taylor? Because Jahn-Taylor effect, for example, if I write D7 configuration for high spin complex, 1, 2, 1, 2, 3. Clear? Yes. It will feel like this: 1, 2, 3, 4, 5, 6 and 7. Now this is unsymmetrical distribution and uneven distribution. Now if I write D8, how to write? 1, 2, 3, that is T2G and AG. This is T2G and this one is easy, and this is T2G and this one is easy. How to fill? 1, 2, 3, 4, 5, 6, 7, 8. Look at, this is unsymmetrical, look at, but this is symmetrical and even distribution. This is unsymmetrical and this one is symmetrical. And the next one is D5. 1, 2, 1, 2, 3. 1, 2, 3, okay, 4 and 5. This is again a symmetrical distribution but uneven, not even. Now D9, let me note down: 1, 2, 1, 2, 3. Clear? Now how to fill? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is again unsymmetrical. This is symmetrical. Okay. Now the question is, Jahn-Taylor effect is not observed in high spin complex. Jahn-Taylor effect is not observed in such high spin complex, such configuration which have symmetrical distribution as well as even distribution, evenly distributed degenerate orbital. 2, 2, 4, 2, 6 and 2. Here is 3 and 2. So this one is that configuration, Jahn-Teller effect is not observed in this configuration. Clear to you? So the answer for this question, that is D8. Is it clear? Look at unevenly distributed degenerate orbital as well as symmetrical. So in this case, Jahn-Teller effect is not observed. Clear? Now I'm going to rub this part and let's move to the next question. Coordination compound is slight confusing. You have to focus on the most important topic, that is CFT and the isomerism in coordination compound. Clear? CFT and isomerism in coordination compound. Question number, now assertion region. Read the question. Linkage isomer arises in coordination compound containing ambidentate ligand. We know isomerism in coordination compounds. Again I am repeating, isomerism in coordination compound. First one is, we know structural isomerism. And the second one is stereo isomerism. Okay, structural isomerism and stereo isomerism. In structural isomerism, we know first one is ionization isomerism. Second one is hydration isomerism. Third one is coordination isomerism. The fourth one is coordination position isomerism. Yes sir, coordination position isomerism. The fifth one is linkage isomerism. Do you remember? Yes, linkage isomerism. And the sixth one is what? The polymerization isomerism. Polymerization isomerism. Is it clear to you? Yeah, ionization isomerism, hydration isomerism, coordination isomerism, coordination position isomerism, linkage isomerism, and polymer linkage isomerism. We know this was given by such molecules, such coordination compound which contain bidentate ligand, bide like NO2. If nitrogen is donor, is nitro. If O and O, oxygen is donor, then nitrito O. Then we will write here CN nitrile. If write NC, isonitrile. Cyno, isocyno. Like SCN, then NCS. This all. If sometimes sulfur is donor atom, sometimes nitrogen is donor atom. These are ambidentate ligand. Now the question here, linkage isomerism arises in coordination compound containing ambidentate ligand. Yes, ambidentate ligand has two different donor atom. Yes, it has two different donor atom, but one time only one donor atom will linked to the central metal atom or ion. So for this question we will say both assertion and reason are true, but the reason is, wait for a moment, but the reason is not the correct explanation. You can say, yeah, what I say, but the reason is the correct explanation of assertion. So for this question I will say that is A is the correct option. Is it clear, my friend? Yes. Let's move to the next question. The next question is, in high spin complex, in high spin situation configuration of D5 ions will be T3 2G and E2G. Okay, in high spin situation pairing energy is less than the crystal field energy. In high spin situation of configuration D5 ion, we know in high spin situation like this, high spin complex, it is not low spin complex, it is called high spin complex, like 1 2 3 4 5. This is the correct order, will be this one. In high spin situation, the pairing energy is less than the crystal field energy. Now got it? Now check the which one is the correct one. Assertion is true, but reason is not completely true. So we will say that is for C is the, for question number 70, C is the correct one. Sometimes one more thing, there is a request from my side, that is sometimes the for assertion region the answer vary. In your book sometimes we will find the answer maybe A, maybe B. So this is assertion region, is depending upon the situation. What I feel as per the syllabus, as per the theory, as per the subject, I am giving you the explanation. So for assertion region sometimes the answer vary, don't get confused, it's up to you, because some predicted, because sometimes reason or assertion are factually correct, not completely correct, but we assume that okay, completely correct, take A, B, C. Even in AIIMS examination you will find it out that sometimes there is a contradiction in the answer. So there is a request from my side. Okay. Question number 71, cuprous ion is colorless whereas cupric ion does not. Cuprous ion, we know copper has atomic number 79. Now it can be written like this, 3d9 and 4s2, but the exact electronic configuration 3d10 4s1. Now when it loses one electron, then what will happen in this case, that is 3d10. (3d10). Now it has completely filled D subcell. Again I am repeating, it has completely filled D subcell. So there is no DD transition. Yes sir. No, again I am repeating, there is no such DD transition. Due to this reason, the compound of Cu plus is colorless, whereas cupric ion, that is Cu2 plus ion, that it loses one more electron. Now the electronic configuration is 3d9. Now 3d9, it can be written like this. One, two, three, four, 5, 6, 7, 8, 9. Okay, unpaired electron. So we will say here that is partially filled D subcell. In this configuration they have partially filled D subcell. If they have partially filled D subcell, then we will say in this case DD transition take place. Again I am repeating, in this case that is DD transition take place. So we will say this statement assertion is true. Cuprous ion has unpaired electron while cupric ion does not. This is completely incorrect. Assertion is true, but reason is incorrect. For this question we will say that is C is the correct option. Am I right? Yes sir, you are absolutely right. So this type of questions are very important for you. Okay. And now I'm briefing the chapter that is coordination compound. What is in this chapter and what we need to focus. I cannot teach completely, but I mean I can give you the normal idea about this chapter. That is coordination compounds. Okay, coordination compound. Now look at. What is coordination compound? We know that if had a complex structure or complex ion, or in coordination compound there is a linking between metal, there is a coordinate bond between metal and ligand. Clear to you? Yes sir. This and this compound are called coordination compound or complex compound. Is it clear to you? First and then second one, you have to focus on Werner's theory. then EAN, effective atomic number. Next, coordination number. Yeah, coordination number here common is 4 or 6. Generally common in coordination compound 4 or 6. Then the next one you have to focus IUPAC nomenclature for anionic complex, for cationic complex, then substance molecule containing both cation and anions, then non-ionic complex. Okay. Then again isomerism. In isomerism, basically you have to focus stereoisomers, and I have given you, I have provided a strong short technique how to find the stereoisomers. You can search this video on YouTube also. Name that is short trick to find the isomers in coordination compound. This is very important. Then hybridization and magnetic behavior. Hybridization and magnetic behavior. Hybridization and magnetic behavior. Then the next one is CFT, that is crystal field CFT, crystal field theory. This is hybridization comes from like finally VV theory, so don't get confused. Then spectrochemical series, and finally organometallic compounds. Next one is organometallic compounds. Again I am repeating, organometallic compound. Last years, in last 5 to 6 years, they basically focus on these two, isomerism or magnetic, hybridization and magnetic behavior. So solve maximum number of questions from this topic, and then I have taken just 2 or 3 questions. It is not sufficient. You have to practice more and more. Just I am giving you just idea. Follow my lecture, definitely help you a lot. I always tell I am not very much talented, my friend, but I have cleared these things one by one during my regular lecture. Clear to you? Yes. So I have taken that, I have covered the first book of 12. That is, in this lecture I have discussed D and F block element and coordination compound. Now in next lecture I will take the organic portion of class 12. That is, I will take some questions from topic haloalkane, haloarenes and alcohol, phenol and ether. Clear to you? Yes sir. Now my friend, time has come, time to say bye bye. Thank you so much.